My name is Pranav Vajariwala. My roll number is 17BP035. Today, as a part of our course Well Test Analysis, the topic which I choose for our assignment is Repeat Formation Test RFT. So starting with the introduction, repeat formation tests are a class of wireline tool used to measure the downhole pressure of the formation. The main objective of RFT is to provide a detailed survey of pressure to the depth in an observation well at a particular moment of time. RFT operation is basically carried out in an open hole during wireline logging operation. The important point to note is that this form of testing is not continuous and it is carried out at a few previously defined depths in the reservoir zone of the well only. Now coming to the operation of the repeat formation tester, two modes of the measurement exist. A pretest measurement and second is the fluid sample measurement. In the pretest measurement, formation pressures are examined, and in the fluid sample measurement, formation fluids are physically withdrawn and retrieved to the surface for examination. Now coming to the RFT tool basically consists of four components. First is the isolation packer, which is used to isolate the mud column. Second is the hydraulic piston, which is used to create the pressure drawdown. Third is the sample chambers, which are used to collect formation fluid samples. And the last is the strain gauge pressure transducer, which is located in the flow line and is used to record the pressure. Drawdown and built-up pressure data for each pretest is continuously recorded at the surface in both analog and digital form. As you can see in this figure, that the tool basically consists of four components. First is the packer, second is the hydraulic piston, which is used to create the pressure drawdown. Third is the sample chambers, that is the chamber 1 and chamber 2, which is shown in the figure. And the last is the strain gauge pressure transducer, which is used for recording the pressure. Now repeat formation test basically is used to determine different properties. First is effective thickness, permeability and porosity, water saturation, oil water and gas oil contacts, pressure and temperature gradient, compartmentalization, flow rates and formation damage. The important point to note is that the RFT tool can be run in the holes with the diameter of 6 3/4 inches and has a pressure and temperature limitation of 20,000 psi and 350 degree Fahrenheit. Now coming to the next is the analysis of pressure measurement. As you can see in the figure, there are two plots. One is flow rate versus time and second is the pressure versus time. In the flow rate versus time, the fluid is allowed to flow into both the chambers, chamber 1 and chamber 2 at different flow rate, that is 60 cm3 per minute and 150 cm3 per minute respectively. And based on that, in the pressure versus time plot, the pressures are recorded corresponding to the time in the different regions indicated in the graph as A, B, C, D, E, F and G. Now when we look at the different regions, starting with the first is the region 1. In the region 1, when the tool is at the required depth but has not been pressed against the wall by the packer, the hydrostatic pressure is equal to the drilling mud pressure, that is depending upon the weight of the column of the mud above it. Now coming to the region B, when the probe penetrates the mud cake, some mud is compressed between the probe and the formation wall. Some mud is compressed between the probe and the formation wall, which leads to a transient pressure increase, which is indicated by region B. As you can see in the figure that from A to B, the pressure is slightly increasing. Now in the region C, the piston is open and the fluid flows into the pretest chamber 1 at 60 cm3 per minute, which is correspondingly shown in the flow rate versus time plot. Now the pressure drops because an additional volume has been added to the chamber, and that's why the pressure forcing the fluid into the chamber is indicated by delta P1. Now in the region D, when the chamber is approaching the full, the measured pressure begins to increase towards the formation pressure, which is indicated by region D in the graph. Now again, in the second chamber, the piston is opened and the fluid flows into the pretest chamber 2 at 150 cm3 per minute, which is correspondingly shown in the flow rate versus the time plot, and correspondingly the pressure pushing the fluid into the chamber is indicated by delta P2, and it is indicated by region E as shown in the graph. Now in the region F, as we can see that when both the chambers are full, the measured pressure begins to increase towards the formation pressure, and as you can see in the graph that the graph is taking some time to reach to the formation pressure. It is because for low permeability formation, the formation pressure does not reaches very fastly. After the pressure measurement, the back shoe is retracted again and the mud pressure is measured again at the point G, which is indicated by the region G, and at the point G the mud pressure is equal to the hydrostatic pressure of the mud column. Now coming to the most important part of the pressure analysis is the data interpretation, which is based on the analysis of the pressure measurement. Now first is diagnosing the fluid contact levels and identifying the pressure transition zone interval. As you can see in the figure that the plot is versus plus. As you can see in the figure that the plot is between the depth versus the pressure. There are three different zones of the reservoir: gas, oil and the water. Now based on this we can very easily identify the fluid contact level, that is the gas oil contact, and second is the oil water contact. Now based on this the pressure gradient are measured at the corresponding depth of the gas oil contact and the water oil contact. So based on this fluid contact level, important mapping of the reservoir fluid nature and the trends and compartmentalization of the reservoir can be identified easily. Coming to the next is the estimation of formation permeability. As you can see in the equation, delta P is equal to C mu Q upon 2 pi Rp Kd delta 1 minus Rp upon Re, where delta P is the drawdown pressure, C is the geometric shape factor for the flow, Q is the flow rate in centimeter per second, Rp is the effective probe radius, Kd is the effective formation permeability, Re is the outer radius of investigation of the flowing field, and all these units are in centimeter. So when the Rp is very less than Re, then the above equation can be reduced to delta P is equal to C mu Q upon 2 pi Rp into Kd, and from this equation the effective permeability Kd can be determined easily, and it gives a very important result in the analysis of the pressure measurement. Thank you, and I hope that the topic which I choose for the assignment was informative, and I am thankful to our faculty mentor Dr. Pawan Gupta to provide me an opportunity to learn and improve my skills on this modern world of digital learning.